Muito boa tarde, prazer estar com vocês. Nós teremos aqui, aliás, já estamos com os nossos colegas, como vocês podem ver na tela, do Instituto Fraunhofer, IPT de Aachen. Eu vou fazer uma breve introdução, vamos dizer assim. Vou falar inicialmente em português. I will ask your license, my friends, to state just the introduction in Portuguese, then we change to English, okay? As we have already talked. Mas eu sei também que os colegas aqui, o Thomas já é também colega de longa data, fala um pouco de português, a Angela também, um pouquinho de português ela fala, tem umas expressões aí interessantes, mas vamos lá. Então, gente, em primeira instância, eu vou falar talvez um pouco em português e inglês, mas agradecendo, né, a todos que estão presentes, o pessoal que vai ver depois mais tarde, nós temos aí hoje a grata presença para estar falando conosco, né, do Digital Twin, né, essa vertente, essa ferramenta nova da parte de quais são, por que é importante, como que isso tende a se comportar no mercado e quais são os benefícios. So I would like to thank you again, thanking Facens, IP Facens, also for sure Fraunhofer Institute from IPT in Aachen, né? Where we have the pleasure to have Thomas and Angela here. I would like also to come back again to Portuguese, just to give some message to the guys, and I'll do it in English as well, okay? Então, gente, eu vou fazer um pouco da introdução dos colegas, né? É uma grata oportunidade de termos aí essas tecnologias de ponta, coisa up-to-date, com um instituto que, com certeza, é o maior, né? Para nos dizer, os maiores de toda a Europa e no mundo, nessa parte de tecnologia, pesquisa aplicada, resolução de problemas. Eu gostaria de aproveitar a oportunidade também, aqueles que ainda não visitaram ou não conhecem, eu vou pedir aí para o nosso pessoal colocar o link da nossa página, né, do IP Facens Indústria 4.0, bem como também os caminhos aí do Facebook, Instagram, e em especial também vai ser colocado um QR Code para aqueles que nós temos aí um workshop, né, temos um workshop específico, hoje é somente uma visão geral, para que vocês possam interagir, perfeito? So, thanks again for the opportunity, and then we are going to switch to English, I guess. From time to time, maybe some questions appears, and we will translate, let's say, according to its coming, ok? Mais uma coisa, aqueles que tiverem perguntas, né, eventualmente pode fazer no pessoal aí no YouTube e tal, eles vão passar para a gente, mesmo que seja em português, a gente pode estar fazendo essa tradução, se for o caso, tá? But first of all, I would like to introduce our friends here from Fraunhofer IPT. Thomas Vollmer is our partner for long date. Since we start with the workshops here, it's always a pleasure to have you here. Thomas is the head of the Department of Production Quality at Fraunhofer Institute, IPT. He is also university lecturer at RWTH, or RWTH, which is one of the biggest universities also in Germany, in Aachen, and he's an expert in digital transformation. Thank you to be here. And I would like also in the same way, before we start with your words and the presentation itself, Angela, I guess people here will call you Angela Massonet. Yeah? She is the research associate at Fraunhofer Institute, IPT, lecturer at South Westphalia University of Applied Science, mechanical engineer, master in mechanical engineer, and expert in software solutions for production. Yeah. So with this presentation, I would like to pass the word, let's say, to Thomas, to Angela. We will have a kind of a presentation mixed with a kind of an interview. Yeah. So please, as people say, the stage is yours. Thanks a lot.
Muito obrigado, Antônio. E boa tarde a todos. Thank you very much for having us here once again, even if it's only online this time. I would have loved to spend the week again in Brazil and have the workshop on site, of course. And I heard that Angela would have loved to be there as well. anyhow, I'm glad that we found a solution that we can still continue in this cooperation and can still have this this workshop here, and can contribute to the digital transformation as you already introduced. And of course, questions can be asked in Portuguese, but I cannot promise that I can answer everything in Portuguese. Also, I cannot promise that I can answer it without a translation from Antonio. So what Angela and me would like to introduce you to is how a digital twin can contribute to manufacturing processes, manufacturing companies, and why it is essential to deal with it. And Antonio, if you got any questions in between, feel free to ask, of course, because as we already had this exchange, I think that is the most promising and most beneficial way to proceed. But in the beginning, companies, especially companies, because in science everyone is convinced that a digital twin is something that companies have to deal with also in manufacturing, but especially companies keep asking, why should we invest, why should we interact and implement a digital twin? So what are applications and why is it so important for us to focus on that? And what we see in science is that the production networks keep getting more and more interconnected, and that also the value chains keep getting more and more interacted, and that also means that products have to interact within the value chain with all the suppliers that are involved in the value-adding process. And that does not also only count for the production, that also counts for medical devices, because we keep getting more and more individualized, and also for smart cities. So if we are talking about energy provision, that is also a major area for digital twins. And the most important thing that we have to understand is that not only the interconnection is something that induces this technology, but also the individualization. If you think about the products that you keep purchasing yourself for your personal belongings, or in your professional business, that gets more and more individualized. Keep thinking about your computer at work, for example. That is nothing that's available off the shelf, but that is individually ordered for Facens, for example. And if products keep getting more and more individualized, of course, the planning, the design, the production, the utilization, and also the maintenance of these products gets more and more complex. Because if I got not one product in the field, but millions, even if all of these products come out of my house, out of my company, then I need some vehicle that contains all the information about that specific product, about that Antônio Gomes specific computer, for example. And that is something that we can use the digital twin for, because it interconnects all the information along the value chain and provides the insights. How has it been planned? What happened in the production? So, for example, did we have any troubles in the delivery of the modules, of the components? Did Antonio didn't use the computer right? Did you make it fall to the ground? So you have some pressure information, for example, which gives us a hint that it is a damage that is made by the user itself, and also gives us insights into how we have to maintain that specific product. And that is perfect for the digital twin, because we do not have to provide tons of paperwork with every product, but we only connect all the information digitally to the, let's say, the serial number or a QR code or whatever. And this specifically and immediately gives us all the information that we need.
Thomas,
And,
we have some key, let's say, key questions that usually the people come to us. Yeah, in this way, we can see you present and so on. That's perfect. But at the end, what is exactly this digital twin? How we can say, oh, this is like this? What is this digital twin technology tool and so on?
That's a very good question, and Angela brought a non-scientific definition for what is a digital twin from our perspective. So I would pass that question to Angela.
Yeah, thanks, Thomas, and Antonio. I'm glad that you're asking because that's the first question that we usually get is what is it? Because a lot of people are talking about it. There are many companies who want to have a digital twin, but it's often unclear what exactly a digital twin is. So let me start at the beginning to make clear where this concept or idea comes from. In the 1960s, NASA produced 2 equal space shuttles. That's why you see those space shuttles here on the slide. And the idea of NASA was to have a second space shuttle on Earth to be able to test the shuttle, to find solutions for issues while the other space shuttle was in operation in space. And based on this idea, where there wasn't yet a digital twin and a physical twin, but 2 physical twins, but the idea that while a expensive and critical product is somewhere else, you have a twin where you can do testing and find solutions. And based on this idea, a professor in Michigan, Professor Michael Greaves, had or developed an idea together with colleagues working at NASA. And they introduced a concept which was comprised of the central elements of today's definition or idea of a digital twin, namely that we have real space, we have virtual space or digital space, and we need to link these 2 spaces with each other by data and information flow. And since then, 20 years ago, a large number of similar but also diverging, sometimes sector-specific definitions have been published. But what most definitions agree upon in the essence is that a digital twin is a representation of a specific item. And furthermore, a digital twin includes the property, state, behavior of a respective physical entity using models, data, and information. And the third important characteristic is that the database of a digital twin contains all data from the entire life cycle, which can be useful in every phase of the life cycle. So some people claim that already a CAD model, for example, is a digital twin. But then when we have a look at these characteristics, these main characteristics listed here, a CAD model is a digital representation of an item, that's true. However, a CAD model contains geometric data, but not necessarily of the current item or a specific individual item. As Thomas said, it's all about individual items. So we want to have the real or the current geometry. And if in manufacturing something went wrong, we do not know about this in the CAD model because there it's only the target geometry. And the idea of the digital twin is to obtain data from this specific physical item and to have really a digital twin, which is not a twin of this product type, but of the individual item. And also the idea is not to have this this representation of a specific item or entity at one point of time, but to continuously update the digital twin so that it always matches the physical entity. So it becomes clear that a main characteristic of the digital twin is this continuous update in terms of data acquisition from the physical space, information generation in the digital space, and then, very important, the return to the physical space. And I now talked a lot, and to make this a little bit clearer, we prepared a visualization of these essential characteristics for you. And here you can see the physical space and the digital space. And we have the physical entity and the virtual entity, and they're connected by data and information flow. And another thing which is very important, which I mentioned before, is the life cycle aspect. So this continuous update, data acquisition and realization, and also then the generated information in the virtual space, utilizing models, utilizing historic data, utilizing also fleet data and environmental data. This information that is generated up here needs to be fed back to the physical entity. And this needs to be done depending on the use case for the complete life cycle. So it's not a one-time event that we update the digital twin, but we do this over the complete life cycle. And also, it is important to acquire data also in the beginning of the life cycle, even if the data is at this point not directly useful to a use case, but becomes useful later in later life cycle stages. So in that way, the database contains all the information from the entire life cycle, but only which is useful to an application. And to make this even more relatable, I want to show you how we at Fraunhofer see the digital twin in production, because we are focusing on the life cycle stage production, which doesn't mean that that we're not looking at the other stages, because the digital twin has the idea of these connections along the life cycle that we do not want to exclude. But here you see how a digital twin is continuously updated through production. There are various production steps, process steps, like milling and laser deposition, measurement, and from a raw part here on the left, which is milled, for example, and becomes a finished product in the end. We have the digital twin in the virtual area, which is continuously updated by the information of sensors and machines. And we see it starts with a CAD model, and later is the exact digital representation of the digital twin. And important, what I said before, is we do not only get data from the shop floor to the virtual space, but also feedback information from the virtual space to employees, for example, to enable them to make good decisions, for example.
Angela, may I? Excuse me for a while. I was just remembered, Angela, when I started early, when I was one of my first jobs as an engineer, I was at the shop floor, and we usually do a kind of a mock-up. Yeah, we take the cartoon. Yeah, we let's say put as a real figure, a real representation, the size of a CNC machine, the trolleys, the operators, and taking time with the the timekeeper and so on, and then we have to stop. It was a fight because we have to finish the line. The production manager said, "Hey, come on, I have to produce items and not stay doing studies." So as I can see, this is very, very applicable to take it and have the things. You have the visualization. You can also take the decisions. You can do it before you go to the shop floor. This is I wanted to make sure that this is the idea. Yeah, if it's okay. And also, I'm wearing the shoes of the companies or the students which are listening to us. How do I can implement it? How I can proceed with that?
Yeah, that's a very good question. So a digital twin consists of a lot of components, or a digital twin has a lot of requirements. And some companies might already fulfill some of the requirements, dependent on how far they already implemented the IoT, so how far they are already digitalized and connected, and how far depending on what IT systems they utilize. But let's say a company starts from scratch, then the first thing you need to do when you start a digital twin initiative is to define your goal. We often see that this sounds trivial, or this sounds too easy. People say, no, let's start creating a digital twin, but the start is really to define exactly what you want to achieve with a digital twin. What is really, you do not want to implement a digital twin just because it's a very popular word nowadays, or yeah, but you want to really have a benefit for your company, for your customers. And a goal could be to monitor your production, to predict quality in during your production, to make your processes more adaptive to. There are a lot of possibilities. Predictive maintenance is a very common goal. And when it is clear what is your goal, then you need to have a look at your at the physical twin of that you want to digitalize. Is it a machine? Is it the complete shop floor? What exactly do you want to twin? And in this product or asset, who else is involved? Is it a manufacturing machine that you bought from your customer, from another company? Or is it the product that you are developing yourself and that you want to sell to a customer and give the customer maybe your digital twin at the same time that you're handing out the physical twin? So who is involved and which life cycle stages are interesting? So do you want to improve the design? Do you want to improve your production processes, or are you looking to, as your goal, to predict maintenance needs for your customer? Or you need to first make sure that you understand the use case that you're going for, and in this context, you also need to look at boundary conditions that might bring you back to the first step. So you need to look at a business model. Is the digital really bringing you the benefit that you're looking for? And what about IT security and legal issues, depending on the use case? So sometimes you need to go back and redefine your goal then. But let's say you did that. You defined the goal, you know which product you're looking at, who is involved, what's your business model, and so on. Then you go to the next layer here, the data management. So one crucial step here is to define which data is necessary. what parameters do you need to reach your goal? For example, let's say you want to do predictive maintenance for a machine, then what are really the parameters that you need to get, and in what frequency do you need to obtain these? Do you need them in real time, or is it okay if you just acquire, for example, vibration data once a week? And when you know what data you need to be able to fulfill your goal, then you need to set up the infrastructure. So sensors, actuators, and sensors can all already mean a worker gives information into the system by hand, for example, or using smart devices. The data then needs to be transferred. And here, this sounds maybe easy to some of you, but the data transfer really depends on the use case or the application. If you have really fast processes and you want to return the information back into the process very fast, for example, you want to improve process parameters in the process, then the data transfer needs to be very fast. Low latency is important. And if you, for example, want to do this on your shop floor for a lot of machines at the same time, then 5G, for example, might be interesting or necessary even for you. So you need to think of the way which type of data transfer is fitting your goal. Then data processing is important, and also the data needs to be stored in a data model and structure. And this is a critical point nowadays, in my opinion, because we do not have a international standard for the data model and structure of digital twins. There are some initiatives and some data models, but there's no international standard, which is important when we're thinking of sharing digital twins or merging digital twins. The data also needs to be stored. And when you have done all this data management, these data management steps, then in my opinion, it becomes really interesting. You're then looking at data or information generation. How from the available data that is now available in the complete life cycle, how do you generate information? And you do this by data analysis, modeling, and simulation. And the information that are then generated need to be somehow brought back to the machines, to the employees, to really benefit, to have a benefit. So you can either visualize them on a dashboard, on a augmented reality application, or you can directly bring back data or information into the processes. And of course, last point here, verification and validation, similarly or analogously to modeling and simulation, which has existed for decades. The results of a digital twin are only as good as the models are. So if your models or your data is not good or good enough, then you will not get the correct results. So verification and validation is a very important step here too.
Yeah, excuse me again. Very, very, very interesting. And then we can have the overview. And I do remember that time ago, some of the engineers say, oh, digital twin is just, let's say, a new word for the old things. And we can take for granted that's not true, because there are a lot of different, the mindset, the way of thinking. And in this way, we can see that it's a kind of a general view, for sure, that during the workshop, we will have more chance to discuss and get into the details. But right now, what are the challenges that you can say to us that is happening when the company decides to go and say, oh, I have a way to go and I will implement digital twin in my company, as an example? What are the challenges?
Well, I totally agree, Antonio. And I already heard these questions myself, but I also heard questions like, how is Industry 4.0 in general different from the CAM revolution in the 80s? Because it's basically the same, which I hope we all agree it isn't. And the digital twin is rather something that is for individualized product, that is always available, that has a very distinct differentiation from mock-ups that you mentioned, because the mock-up is only present at one entity, and it is not available from all over the world. And for everyone who has the access to the digital twin, it doesn't represent any behavior. It only shows how it will look like, and that is completely different when it comes to the digital twin, because as Angela said, the idea is to have something that can also not just simulate but show how the behavior would look like, because it contains all the information what happened to this product only in a digital way. And when we are talking about digital solutions, we have the conventional issues that we're having. First of all, I was already talking about accessibility, and this also accounts, for example, for the digital twin, because we have to think about who will be granted to have the access to the digital twin. Can we grant the access to every information, or only to single information, or only to single stages in the life cycle of the digital twin? If you keep thinking, for example, within a value chain, there might be information on the digital twin from suppliers that they don't want to have shared with everyone who is subsequently in the value-adding chain. And this is something with regards to data sovereignty. Of course, we have the issues of IT security. If we're thinking about who has to guarantee that the data that is attached to the digital twin does not come into the wrong hands, and who will be charged for the damage that is being caused, if you're thinking about intellectual property that accidentally will be shared. And of course, we have also we have to deal with the question, how can we assure that there is a proper connectivity when it comes to data formats? We have to assure that everyone is capable of using the digital twin. So we have to talk about compatibility, and have to ensure that everyone is able to use the digital twin in the way that it is meant for. And I think those are the main advantages. We put some here in the middle and some around on the slides, but I think those are the main ones that also hinder companies right now to implement a digital twin, because at least in the manufacturing companies, the solutions from a legal perspective have not been 100% answered, or at least the solutions from a legal framework haven't been transferred to manufacturing companies. That's why there is still some anticipation of problems when it comes to the digital twin, which at least in the European Union there are a lot of initiatives dealing with data sovereignty, IT security, and how to assure that there is a legal framework that makes it possible and guarantees for everyone who is participating with the right infrastructure that the data will be secure, and that there won't be any accidents. And if there will be something, that at least it is clear from a legal perspective who has to be charged for that.
Yeah, that's amazing. Yeah, I was just wondering as well, because, you know, this is somehow new for the attendees, new as an example, new in the world. And I was wondering, how does digital twin look like? I mean, is it somehow touchable? It's a frame, I need to have a computer in this way. And wondering also that there are some questions, what are the fields of application of it? We can use everywhere as we need in this way. Can you please talk a bit about it? Thank you.
Yeah, I would like to show you some use cases or applications from our institute that we're developing there to make this more understandable. And digital twins, depending on the application, can look differently. But we brought a few examples here to show you how a digital twin can look like, for example. So what you see here is a tank, which is manufactured in layers by fiber reinforced plastic. And this tank might be used, for example, for hydrogen storage. So it needs to be there shouldn't be any legs. And what is done usually is they are manufactured, and then in the end you're checking the quality. And the idea is to not manufacture a number of products and then in the end check the quality by either destructive or by radiology, for example, but while the process is ongoing, to predict or to determine if the quality is okay or not. So what is done here is the pressure from the manufacturing machine, the pressure that the layers are put together, is detected by a sensor and stored on the geometry. And furthermore, because this plastic is glued together by heating and by laser, which induces heating and the applied pressure, the temperature is also acquired and visualized here above the surface. And then using models, we are able to predict using this real pressure and temperature data for each product and each area to determine if somewhere critical areas exist or the quality is not sufficient. And these critical areas that you see here now on the right, these can be made visible on a dashboard or at a computer or even smart glasses. And this is very helpful because you can then stop the process right away. You do not need to wait till the process has finished. You could even change the parameters, increase temperature or pressure, for example, in the process. So you will reduce your scrap rate, you will reduce manufacturing times and improve your quality. And another example of a digital twin is the digital twin of a blisk. We manufacture blisks, among others, in milling centers. And these blisks are basically turbine blades. They have a very complex geometry, and because they are for aircrafts and need to resist high temperatures, the material is very difficult to manufacture, to mill, and also very expensive. And this milling process for the complete blisk takes a lot of time, and the material is expensive, as I said. So we would like, same as for the tank, the tank of fiber reinforced plastic, we would like to not wait till the end of the process to see if the product, the quality of the product, is sufficient or not, but we want to know it during the process to be able to either stop the process right away or to even improve parameters. So what is done here to create a digital twin of this blisk is the axis position data of the milling center, the machine tool, is utilized, as well as additional sensor data. For example, vibration data of the manufactured product is acquired. And in addition to this, same as the example before, models and simulations are used to predict, utilizing the sensor data from the current process and the current product, to predict how the surface quality will be like. And you see here visualized areas of not sufficient surface roughness, for example. And this data can be visualized then either on an app, or even the data could be fed back directly into the process, and to make the process better right away. But the second is way more difficult and challenging, because you ask for challenges. This is definitely a bigger challenge to not only monitor or provide current data or current or information from the current data, but even to predict or prescript optimal parameters and to feed them back. And as a third example, I want to show you how information can be directly utilized for workers. Here, for example, showing remote maintenance. So a worker using smart glasses is doing maintenance on a machine, and either gets support by a person who's not there, or a digital twin can be visualized using augmented reality to display specific issues of the machine, or historical data of the machine, and can thereby assist the worker.
If I may add a few things. First of all, this guy here in the picture is a student of your university, by the way. Just a fun fact.
I was wondering. It looks like the mechanical one, yeah.
Yeah, exactly. Yeah, we met him last year during the workshop. And because you were asking regarding the application scenarios, this is something that you can use as a role model, how to use a digital twin. Because if you think about the pressure tank, first of all, you can see what has exactly happened at which point of time, at which geometrical position, and you can then use these information whether everything went in the right way. Of course, that requires information regarding the tolerances of your production process, but I would assume that a manufacturer knows about what has to in which boundary conditions you have to execute your processes, and this also helps for quality control without being able to have some X-ray or whatever you can imagine as a very effort-intensive operation afterwards. And also, if there is a complaint, for example, in the field, and this states that that you induced some some problems during the manufacturing, you can prove that that isn't the case in reality. And in the second example with the bliss manufacturing, you can also use it. This is a connection between the manufacturing and the utilization or maintenance. And the second example is an example that you can also use in the interface between the design and the manufacturing, because in the first place you can use the digital representation of your milling process. If you understand deviation of your tooltip and vibrations of your workpiece, that helps you to understand whether the manufactured piece has exactly the geometrical shape of the design that you developed. So it helps you to see whether the manufactured part is a good one, and also has the same operational benefits with the utilization and the maintenance. But also, as Angela said, has the benefit also, although it is very complicated, of course, to provide adaptive processes that you can immediately react. Of course, that requires, again, different technologies such as 5G and edge computing. But as far as I know, you're currently involving at the university in 5G for manufacturing as well. So that is something that enables a manufacturer to deal with adaptive process control as well. So this are very powerful applications that requires a digital twin, because otherwise it's just not possible. Or you have to deal with tons of paperwork, and even the information might be there, you will never find it if there is a very specific complaint or claim.
Yeah, totally agree to you. May I ask some questions? We have some participants here, some attendees. I would like to say that it was a glad surprise that a friend of mine, which we work in a huge company here in the area, he said to me, "Oh, that's fine. Thank you for the opportunity." They are in a room, yeah, with some other guys listening and talking and so on. And some questions appears. May I start with some questions?
Sure.
Okay. So there is one that will be difficult. Difficult because okay, step by step. The first, you gave some example to us, but can we use this approach for hospitals or some malls or some service center? Is it possible to use?
I would say it depends on the use case. What you would like to do in the hospital. If it is about individualized medicines, then of course temperature, pressure levels in milling operations are just not helpful. If it is about, but in general, the approach is totally transferable. If you're thinking about, for example, individualized medication, then you have to collect different information, of course. You have to you need physical information about the patient. You need you need information about the disease. You need information about stem cells, for example, that you can transform into certain cells or certain biological material that you have to that you need for your vaccination or for your medication. But that indeed is possible. But of course, this is a slightly different approach from an engineering perspective. But the overall idea of the digital twin stays the same. And of course, if we're thinking about the application area, if we are talking about medical devices, then of course we can use that as well. We get some devices, for example, automated stem cell manufacturing. That is why I'm mentioning the stem cells, and that in the end is a physical machine that executes manufacturing operations, even if it is on biological levels and executing biological processes, but still you can use it. You have different challenges, you have some uncertainties in the developments of the biological material, but still you have development times, you're having stages of within the development process and so on. So this is something that you can definitely use for the digital twin as well.
Okay. So
Thomas, let me add one thing. I totally agree with everything you said, Thomas. Just one thing that I want to add is that the reason why we're currently finding digital twins mainly in industrial applications, so industrial equipment such as motors, pumps, machine tools, these are all expensive products or assets, and they're very critical. And because a digital twin at first costs you money to create it and implement it. However, we see that the technology costs are dropping and have been dropping for the past years. And I'm quite certain that we will see more digital twins coming up, being used in other areas other than industrial applications, such as healthcare and smart cities that Thomas named in the beginning. Because I think the main reason why we're not seeing this, for example, a digital twin for mice or mouse, it is expensive. And is it really worth it? But yeah, we will see more digital twins in other areas, I'm sure.
Okay, thanks a lot. Because this way of thinking, this mindset leads us for the next question, which is related to. I'm going to mix three questions here. It comes from Rafael, Ricardo, and Bruno. Okay. Specific point, okay? Probably we have a kind of an influence. Probably we have we do have an influence where what we are talking about, if you are talking about South America, if you are going to talk about Europe, and more than this, we have an influence of the hard times that we are living right now. And the question goes in the way like this. How soon, this is from Rafael, how soon will this new technology be present in industries? At least 80% of them. I guess this is hard because we have a lot of influences about the time that we are living right now, and also according to the region that we are talking about. Maybe you can have a ungefähr. Is it correct, the word? Somehow in Deutschland or in Germany or something like this. Is it possible to answer this question?
So your answer, the question is about the time when 80% of the companies have a digital twin implemented. Okay. Maybe from here to 5 years, a month, or 10 years. Just a feeling about.
So I know that there's a Gartner study. They conducted a broad study and estimated. I think for 2022, they did this study in 2017, and they estimated, but I don't remember the number exactly. I'm sure, or I think that they said something about 60–70% of the companies in the production sector will have a digital twin initiative. But I think everybody needs to fact check this. I'm really not sure, but there is a Gartner study which is really good, and they make projections. It's 2 or 3 years old, but it gives you a broad number. But I have to say I was really surprised because I remember that the number was quite high, and I compared this to my experience with companies, and I'm personally not convinced that we will have 70 or 80% in the next year. Thomas, what do you think?
I think
it's a hard question because it depends a lot of influences according to the region and the things like this. But may I have a kind of a compromise here to the Rafael? Yeah, Rafael, send us your email through the box or YouTube or whatever. And we were looking forward for this because it was really a good question for us. Hard to say, but good. And also in this way, talking about the regions. Sorry, please, Thomas. Would you like to say something, Thomas?
I didn't want to interrupt, but I think the question is also hard to answer because everyone who keeps talking about the digital twin discusses different levels of detail. For example, our understanding is the complete value chain. If someone has a digital twin for one specific product, because that's the high runner, for example, that also counts for this number, of course. So it is hard to say that company has implemented a digital twin and that doesn't, because that doesn't have implemented a digital twin, because our recommendation is always to implement it in a way that it is beneficial. And for some companies, that that means that they have to implement it for their whole shop floor, for all the manufacturing machines, for all tool machines. And for other company, it only brings benefit if they use it for their high runners. For example, if you're considering Apple and their iPhone, they can virtually give you some information about what's going wrong if you're having some troubles. And I think it wouldn't be valuable to create a digital twin for all the products that are in the field. For example, for the first iPod that has been introduced in 2004 or whenever, that's just not economic. So it is important to implement it in a way that it's bringing benefit to the company. And if it is only in one point and they introduce a digital twin in the very specific area that brings the benefit, then I would say we are on the way. And if we are thinking that a company has to be fully digitalized, then I would say that this will never happen.
Yeah, it's thanks a lot for the view and the explanation. I agree to you. Yeah. Because we have different levels. By the end, what's necessary for the company to do your product, to provide the service, and so on. There are some few questions. I guess we can we extend more 10 minutes? Is it okay? Okay, so there are some questions that I'm going to put together. There is one about if it's necessary for the professionals to know all the things, and close to this also, how the small or medium-sized companies can assess this technology. I would like to have a comment on this one. One example is like we are doing right now. Yeah, we have the Fraunhofer Facens partnership. We have our courses, extension courses. We have the lab, which we started at 2018 together, Thomas. Yeah, we have the opening. So in my point of view, how to prepare and how the small and medium-sized companies has the access to it is to have this integration of the companies, education center, as Facens, we have the labs and so on. But I would like to also to listen to you, please.
I think that it's that especially small and medium-sized companies, they have to start on a basic level. So first of all, understand the concept and understand the power of the digital twin and what you can use it for. Because only if you're having this understanding, then you can start elaborating what beneficial use cases would be. And depending from the use case, that also helps you to define the technical requirements that you have. So the ones that Angela showed with regard to storage, with regard to computing, and so on. So this is something that you cannot answer in general in the beginning. So this is very application driven and specific regarding the use case. And I would always say these technical questions, technical issues can always be solved by experts in that area. If you got the right understanding for the digital twin and you define a use case, then to buy, let's say, the competencies in the IT domain, this is pure engineering. So that can be then be implemented and executed afterwards by an IT professional, for example. But first of all, what is important is that manufacturing engineers have a certain understanding of IT technologies, of digital services, and can transform that into their manufacturing environment. Because that's the starting point. If you say please implement a digital twin, that's a non-realistic question. And if you start with a certain use case, then you can, for example, with the pressure tank, let's make it tangible. You wanna monitor the manufacturing. Then you have to think about what kinds of information can we collect. That's temperature, that's pressure, that's the gluing time. So what do you need from a technical perspective? You need a temperature sensor, you need a pressure sensor, you need a clock to count to set up the time, and then you have to have someone at hand that helps you with the database to set up the data storage, and you have to have someone who gives you insights into the data volume that you need based on the frequency of the data that is being collected. And then you get step by step towards the digital twin implementation. And you do not have to be the expert yourself in the digital twin, but you have to have the basic understanding, and then you can collect the required competencies from other domains.
Perfect, Thomas. Perfect. I saw that Angela puts on the screen. Would you like to comment on some remarks about the presentation itself, Angela? I mean, it's on the screen. One slide on the screen.
I put the slide on the screen because Thomas was referring to it, and I completely agree to what Thomas said. And in essence, you need not to be able to do everything, all these steps, or fulfill all these requirements by yourself. But I think important is to partner up with either research institutions or other companies that are specialized in networking, are specialized in AI, or so on.
That's great. That's great. Yeah, I'm glad that our working institution, that we have, as we said, this integration to the companies, to research institutes, to reference institutes as yours, and the people who are they are also, or let's say, sometimes more worried to develop, to give some competences to the students, to the market, to the community, and so on. I received a message here that we have some more few questions, but since we are finishing, I would like to take those questions, which are very specific ones, sometimes about predictive maintenance and so on, that I kindly ask that people send to us in order to be answered, because I know that it's getting late in Germany. We have at least 4 hours difference, yeah? And then I'm coming to the finish here. Before I finish, I would like to ask to Angela and Thomas to say, let's say, farewell words, and we will be nearby. And then I will close and thank you again.
Angela, ladies.
Thank you. Thank you, Antonio, for having us. Estou feliz em falar com vocês sobre o tema Digital Twin. So I'm really happy that we were talking.
Good. I guess we have a bad connection, but I guess Angela, would you like to say something more, or Thomas?
well, as I already said in the beginning, I'm always happy that we are having this exchange, because for me it's a lot of fun to discuss these issues, and also the questions that give us some impulses. What are the questions that companies are dealing with? And what I also like about this cooperation, Antonio, is that based on one of the questions that we were just discussing, how the engineering requirements are changing over time. When we met for the first time, we were dealing with energy efficiency in manufacturing, and for the last 4 years, I think 4 or 5 years, we are more and more dealing with digitalization, with data management, with digital twin, with AI, and I think that that shows that engineering and engineers have to gather more and more IT competencies that help in working in the daily business. And I think Facens is the perfect institution to gather these competencies, because I know from the opening of the Industry 4.0 laboratory that there is everything available, and we have a very good playground to answer these questions in a physical and tangible way. So I'm really happy to be there at the next workshop and to see how everything developed from the opening towards today, and what else can be integrated there for as I said, for example, 5G, and to sharpen the understanding for IT services in the engineering domain. So really looking forward to that, and thank you very much for having us here.
So always a pleasure. So glad about the words and the view that we have together. Thanks a lot. And I would like also to go into the finish here to thanks again to Centro Universitário Facens, to Fraunhofer Institute, for the guys which are here, also to Stefania, Elise, Marcos, which are behind in providing us the quality of the show here, let's say. And I guess we are, let's say, keep in mind that we have the QR codes and we have the workshop starting by March 29, yeah, and we'll be together having more discussion, going deep into these questions and remarks. I have to say that it will be, what's the word? It will be a show. I mean, this is exactly what we need. This is what we have discussed here. Again, thanks to all of the support for the guys. And farewell. Let's see. Thanks a lot, and see you not so far, at least for sure, by March 29. For the ones which wanted to also to see something.
Thank you very much. See you soon. Stay healthy, of course.
Yeah, that's it. That's it. Okay.
Yeah, thanks so much. I'm looking forward to doing the seminar with you.
It will be a pleasure. So thanks to the participant, thanks everybody. See you not far and safe. Bye now, thanks a lot.
Bye.
Bye-bye, auf Wiedersehen.
Bye-bye.
Auf Wiedersehen.
Auf Wiedersehen, vielen Dank. Tschüss.